Hello students, welcome you all to the discussion on the next session regarding the problems solutions for the STEAM which you have seen in the previous session. So in the previous session we have discussed regarding how to refer to the data using a STEAM table to solve the problems on the STEAM formation. So in the previous session, we have also gone through the STEAM table where how the various properties, that is the specific enthalpy, specific entropy, as well as specific volume, temperature, pressure, how they have to be extracted from the STEAM tables, that already we have discussed in the previous sessions. Now in this session, we'll be studying regarding some examples, and in these examples I told you we extract the values from the STEAM table based on the pressure basis or on the temperature basis. So around 3 problems I have taken in this session where I will be discussing regarding these 3 problems, and in these 3 problems we'll be seeing how the different properties of the steam, how we are going to extract them from the STEAM table, and how we are going out to carry the solutions for the given problems. So now let us see one by one how the solutions can be carried out using the STEAM table as we will discuss right now. Yes, the first question which you are observing right now here is we have to find the enthalpy of 1 kg of steam at 12 bar when steam is dry saturated, steam is 22% wet, and third case it is superheated to 250 degrees Celsius. Take the specific heat of superheated steam as 2.25 kilojoules per kg Kelvin. So now in this question you are seeing that the mass of steam given to you is 1 kg, and the steam which you are using here, it is developed at a constant pressure of how much? 12 bar. So here said at 12 bar the steam is being developed, which means now you have to refer to the steam table based on pressure basis. Why? Because in this question he has said the steam is developed at 12 bar, means at this pressure the steam is developed. The mass of steam is 1 kg. He has asked us to find out 3 criteria, that is enthalpy. You have to find it for 3 cases. One is dry saturated, the other case is 22% wet, and the third case is superheated to 250 degrees Celsius. So for superheated, we need to take one term for our analysis purpose. We call the term as specific heat of superheated steam, which is written as CP sup. Specific heat of the superheated steam, that is CP sup, CP sup as 2.25 kilojoules per kg Kelvin. So even in the question, if it is not given, you can assume this as your standard value when you are finding for a superheated steam. So for all 3 cases, we need to find out the enthalpy. The enthalpy, what we need to find out, if it is dry saturated, already we have discussed regarding the symbols and subscripts also. Specific enthalpy H. If it is a dry saturated, then the subscript is Hg. This we need to find out. Second case, he has told it is a 22% wet, means there is some amount of dryness fraction. We have to find it out, that is the X. We have to find out that dryness fraction, and then we need to find out the enthalpy of this mixture, that is the wet steam, that is H suffix F, or it is H suffix W also. So this is HFG. Then the next thing is you need to find out the enthalpy of superheated steam. Enthalpy of the superheated steam. So for enthalpy of superheated steam, we have to find out H sup. So we need to find out H sup. So for this H sup, we have an equation, that is H sup is equal to Hg plus Cp sup, that is specific heat of a superheated steam, Cp sup, into T superheated minus T saturation, T superheated temperature, T sup, minus T sat, that is the saturation temperature. So already in this problem, the value of the superheated temperature is given to us. It is right now here mentioned, that is 250 degrees Celsius. This value is given. but we need to find out the value of saturation temperature T set. So this we will be finding using the steam tables. So now we'll go to the further part regarding how these have to be extracted from the steam tables. So given things, as I was telling you, the mass of steam given to us is, it is 1 kg. Pressure, so here the steam formation which is happening, it is happening at a pressure of 12 bar. So you have to refer to the steam tables. And one more point I will tell you, I was telling you that in some steam tables the pressure values are written in terms of bars or in kilopascals or even in megapascals. So make a note before you go for the referring the values according to your question. Now in a question, what he has told for 12 bar. So in some steam tables, it may be the pressure may be in terms of bar, the first case, or it may be in terms of kilopascal, or even it may be in terms of megapascal. So the question what he has given you, he has given you with respect to bar itself. So now what you should do, you should convert this bar with respect to the steam table what you are having. So if in a steam table it is there in kilopascal, so convert that bar into respective kilopascal, or if it is in megapascal, then convert it into respective megapascal and then go for referring your values. The steam table which I have used for this problem solution, its values of pressure they have given in terms of megapascal. So what right now I am doing is I am converting the value of 12 bar to respective megapascal such a way that I can understand what is the respective value to refer in the steam tables. So 12 bar, so 12 bar I am converting this into 12. This is exponent 1 10 to 5 Pascal. So if I multiply and divide both by 10, so if it cancels, then what happens? Again, we get the same value. So if I multiply 10 raised to 5 with this one, multiply and divide, then what do I get? So multiplying and dividing by 10. So there is no change, which means when I multiply with respect to 10, what happens? This becomes 10 raised to 6. So 12 into 10 raised to 6 is 12 megapascal. 12 megapascal by 10, what we get? I get as 1.2 megapascal. So why I am doing this one? Because the steam table which I have referred for this calculation, it is given the values of pressure in terms of megapascal. So take care when you are referring the steam tables, check the value of pressures in which units they are mentioned. If it is mentioned in bar, it is well and good. You can refer data directly. If it is in kilopascals, then convert that bar into respect to kilopascals. If it is in megapascals, so convert that bar into respect to megapascals and then go for extracting the data. So I have told you this one. So once again, I am writing here the pressure value. It may be given in terms of bar in some of the steam tables. In some of the steam tables, it may be given in terms of kilopascal or in terms of even megapascal also. So with respect, if it is given in kilopascals, convert the bar into kilopascals, or if it is in megapascals, convert the bar into megapascals and then go for referring the data. So now we shall move forward. So very important thing is, now when you go to the steam tables, I told you we are having two types of steam tables. One is based upon the temperature basis and the pressure basis. So the properties which we are referring to our steam table, it is based upon the pressure basis, where you have to refer to these properties, that is saturated water and steam properties based upon what? Pressure. Why? Because the steam developed in this case, it is developed at a pressure of 12 bar. This has to be taken care. Now, the next important thing is, yes. So here I have shown you regarding, this is the steam table, which is based upon the pressure basis. So see, you have to go for a steam table. In the bracket, it should be written based on pressure. And once it is based on pressure, the next important thing is the first column which you are referring, it should be in terms of pressure. Means taking pressure as a reference, the other properties have been calculated. So now for our question, we are having that we have to find the values of a specific enthalpy of steam at 12 bar. So as it is in megapascal, already I have shown you, I have converted it into respect to megapascal, and I have got the value as 1.2 megapascal. I have got the value as 1.2 megapascal. So at 2 megapascal, if you observe the second column beside the pressure, this is nothing but it is the value of saturation temperature. So 187.957, what you are seeing here, it is the saturation temperature at this particular pressure. So you can see at the top of the column also it has written Tsat and degrees Celsius. So always keep in mind, after the pressure, whatever the next column is there, it is the saturation temperature. So at 1.2 megapascal or 12 bar, the saturation temperature is 187.957 degree Celsius. Now, we need to find out the specific enthalpy as given to us in the question. So if you observe carefully, here already I have highlighted these things. So this is the enthalpy column, and it has three sub columns. So this enthalpy at the fluid phase, HF, enthalpy at the dry vapor phase, HG, mixture of vapor and liquid, HFG. So these are the values, that is we have to extract from the steam table. HF as 798.33, HG as 2783.7, HFG as 1985.4. These values we extract it from the steam table. So when you are writing in your notes, you have to write from the steam table at pressure of 1.2 megapascal or 12 bar. These are the things we have been extracted. So let us see how we do this one. Yes, as I told you, at a pressure of 1.2 megapascal or 12 bar, it writes these things as per steam table units. So we have, so as I was telling you, saturation temperature is 187.957 degrees Celsius, and the other properties we have written here. Now, for the calculation part, we need to find out the enthalpy of a dry steam with the mixture of a wet steam as well as superheated steam. So the same things we have carried out to here, and now let us start the calculation. So the calculation is the first for a dry steam. So for a dry steam, the equation which you are using is this one: Hg is equal to Hf plus Hfg. So Hf means enthalpy of the wet steam, which you are already having here. Then Hfg is a mixture of this one. So together, how much we get the value? 2783.73. This is actually when the steam is purely dry, that is 100% dry. This value we get. So even in the steam tables, the column which you are writing Hg, it is nothing but for the values of 100% steam itself. So you can solve by using this equation, or if it is a dry steam, directly you can take this value also. Both are same. You can cross check here. This value and this value, both are same itself. This is for a dry steam. Now, when the steam is 22% wet as per the given condition, then what happens? We need to find out the dryness fraction. And what we are using the equation, if you observe carefully, the equation for the calculation of wet steam, we are having HW. HW is equal to HF plus XHFG. So what is this term X? This X is used for calculation of dryness fraction. So how we calculate dryness fraction? This is the equation here. X is equal to 100. In total 100, how much percent it is wet? 22% it is wet. So how much it will be dry then? It will be 78% dry, or it is nothing but it is 0.78. So in this equation, we substitute the value of X, that is HW is equal to HF plus XHFG, and substitution we get this value, that is 2346.942. So always remember in mind, when he says in the question that the steam is 20% wet, means it is 80% dry. If he says it is 30% wet, means it is 70% dry. So how we have to calculate? Using this equation, that is X is equal to 100 minus 22, we get the value of the dryness fraction, and then we include that value in this equation to get the following answer. Now we have found out for second case. Another case which we have left is with respect to the superheated steam. So for superheated steam, yes, I was telling you, we use this equation H soup. When we use the H soup equation, it is H soup is equal to Hg plus Cp soup into T soup minus T sat. So saturation temperature, I just now I shown you that from the steam tables we get this value. Super temperature is already given in the question. Along with that, even the Cp soup value is also given, that is Cps. So its value is how much? He has given 2.2 kilojoules per kg Kelvin. T soup is also given. Hg we have extracted from the steam table. T sat we have extracted from the steam table. We substitute here and we get this value, that is enthalpy of a superheated steam. So these are steps you need to follow when you are solving a problem on the steam table. So as I told you, the first very important thing is you need to decide whether the steam table is based on the pressure basis or on the the question in what he has given regarding the formation of steam, whether it is based on the temperature basis or pressure basis. So as I was telling you, whether it is based on temperature and pressure basis, once you get the value of this, it is on pressure basis, then you have to refer for the steam table based on pressure. You need to extract the values. After you extract the values, do the respective calculations and you get the answers. Similarly, we'll go for a next problem, just a simple manner itself. Yes. In the next problem, what you are seeing here, he has said you need to calculate the enthalpy of how much? 3 kg of steam. So the steam what you are using here, it is nothing but it is how much? Mass is how much? 3 kg of the steam. It is developed at what pressure? 10 bar. So you have to convert this 10 bar into respective megapascal or kilopascal as per the value of pressure in your steam tables which you are using. So he has told to what case you have to find the specific enthalpy. Again, when the steam is dry saturated means Hg. He has said here 15% wet. So 15% wet means 100 minus 15. How much we get the value? The dryness value, it is 85%. So for this 85%, you need to find the value of wet steam, HW. Then superheated to the conditions of how much? 200 degrees Celsius, 200 degrees temperature. Specific heat is how much? I told the standard value is 2.25 kilojoules per kg Kelvin. So these are the case. Here also in this problem also he has told that whatever the steam is developed, it is developed at what conditions? It is developed again at the pressure itself. So even this steam, it is developed at the pressure itself. So now let us see how we can solve this problem here. Go on to all the steps which I have said. So the first important thing I told you, total mass of the steam given is 3 kg. Pressure 10 bar it is there. So I have told you according to your steam tables, check the value of the units of the pressure which is given to you. If it is in megapascal, convert to megapascals respective from bar to megapascal. Similarly from bar to kilopascal also. Now it is in megapascal. So I am doing the conversions here. 10 bar, 10 into 10 to 5. 1 bar is equal to 10 to 5 pascal. So I have taken it here. Or if I multiply and divide by 10, then what I get? The corresponding value of bar 10 bar as it is 1 megapascal. So now I'm using a steam table where the pressure values are mentioned in the terms of megapascal. So let us see what we can get the next things. So as I was telling you, we go to the steam tables, and here also as the steam is developed at 10 bar pressure. So here also we are measuring based on the pressure itself. So we are referring to a steam table which is developed on the pressure basis. So here on the pressure basis, yes. So 10 bar means it is 1 megapascal. So if you observe here at 1 megapascal, again we are extracting the value. So at 1 megapascal, what is the saturation temperature? It is 179.878 degrees Celsius. Then the enthalpy properties we are extracting it. These are the enthalpy values, specific enthalpy values. Remember these specific enthalpy values which you are taking out. It is for what conditions? It is for kilojoules per kg. For every kg, these are the values. But in our question, what he has said, you have to calculate the enthalpies for how much mass? 3 kgs. So once you get the values of enthalpy, you have to multiply it to the total mass and get the respective answer. So let us see how we can find these things. Yes. So at 1 megapascal or 10 bar, we have got these values from the steam table, which we have extracted. Then, so as I told you, for a dry steam, we have this equation, or directly you can take this value also directly from steam tables. You can take this value for a dry steam. The same we get here also, you can see here. But the thing is, this is for what? For 1 kg of steam. This value you are getting for 1 kg of steam. In our question, how much he has asked? 3 kg of steam. So what we should do? We should multiply this value with the 3 kg of steam, which we have done here. So then how much we get the answer? This is the enthalpy of which kind of steam? Dry steam for 3 kg. Similarly, you have to do even for the wet steam as well as for the superheated steam also. Let us see. So for the wet steam, yes, we use the same equation. HW is equal to HF plus XHFG. This is the equation we have used. So as he has told, how much percent it is wet now? It is 15% wet. So 100 minus 15, we get the dryness fraction. That is the value of X. So how much we get? It is 85% dry, or X value is equal to 0.85. So we substitute the value of 0.85 in this equation, that is here, and we get the value as SW is equal to 2474.93 kilojoules for how much? For 1 kg we are getting this one. This also we are getting for 1 kg. We need it for how much? We need it for 3 kg. So for 3 kg, we multiply this one, you will get the total answer. This is the value for 3 kg. Similarly, for superheated steam, we need to follow the same steps. So for superheated steam, we have the equation H sup is equal to Hg plus Cp sup, T sup minus T set. So in the question, in the steam tables, you have taken the value of Hg, you have taken the value of saturation temperature, Cps value, it is given in the question. Similarly, super temperature is also given to you. So we write that values. Again, even this value which you are getting here, H sup, you are getting for what? You are getting for 1 kg. So for 3 kgs, how much value you need to get? So multiply by 3, you get the total answer. In this way, we need to find out the enthalpy of the steam for the value of 3 kg. This is also based on the temperature itself. Now in the next problem which we will be discussing, even this problem is based upon the pressure basis itself. The next problem which we'll be discussing now, it is based on temperature basis. So let us see what do we get there. Yes. The third problem which we have taken here is we have to find out the enthalpy of how much? 5 kg of steam. We need to find the enthalpy of how much? 5 kg of steam. And this 5 kg of steam, how it is developed? It is developed at what conditions? It is developed at a temperature. So in this case, now what is the reference now? Temperature is the reference, which means you need to refer to a steam table where temperature is your first column as your reference. So now you have to refer to a steam table where it is based on temperature basis. He has given two conditions here. One is you have to find the enthalpy at dry saturated, that is 100% dry, that is the value of Hg. Another one he has said 30% wet, that is the value of HW. So if it is 30% wet, then for X value, how it is? X is equal to 100 minus of 30. X is equal to 100 minus 30, which means we get it as around 70%, or it is 0.7, 70% or it is 0.7. So these things we need to estimate now. Let us see how we can do the solution here. So as I'm telling you, the mass of the steam given to us is how much? It is 5 kg. Temperature is 110 degrees Celsius. So as that steam is developed at 110 degrees Celsius, I told you we are referring to a steam table which is based upon the temperature basis, So if you observe right now here, the steam table which we are using now, that is saturated water and steam, it is on what basis? Temperature based basis. And you can see the first column is temperature as your reference temperature. So temperature is taken as reference and the other properties are being estimated. Now when the temperature is taken as reference, the next column which you are seeing here, it is the saturation pressure. So in the previous problems, when pressure was taken as our reference case, what was the second column? We are having saturation temperature. Now here what we are having saturation pressure. It is also in terms of megapascal. So he has said 110 degrees Celsius. So if you see at 110 degrees Celsius, already I have highlighted, this is the value of the saturation pressure in terms of megapascal. Similarly, these are the values of enthalpies. These are also again in terms of, the units are given here, that is in terms of kilojoules per kg. So let us see how we can solve this problem now. Follow the same steps which we have done for other two cases, you get the answers. So from steam tables at 110 degrees Celsius, I told you the saturation pressure is 0.14338 megapascal. HF value we have written 461.42 kilojoules per kg. Hg value is 2691.1 kilojoules per kg. HFG is equal to 9.6 kilojoule per kg. Now, yes, if you come to the solution part, if you observe carefully, we have taken this equation and we have written that for the dry steam, this is the equation, Hg is equal to Hf plus Hfg. Even this value is directly available in the steam table also. This is for 100% steam, or it is for a dry steam also. The same value we get it here. But whatever the value you are getting for how much? We are getting for 1 kg steam. We need for how much? 5 kg of steam. So for the answer what you have got, if you multiply with the value of 5, then we will get for net 5 kg of steam, what is the enthalpy? That is 13,455.1. Remember, the units written will be now only in kilojoules because there is written for 5 kilojoules of steam. This is the first case. Now, the second case we are having for the steam which is how much? 30% wet as per this given condition. So as 30% wet, yes, we have written here the x value now becomes what? 100 minus 30, it is 70% dry, or x value is 0.7. So the equation becomes HW is equal to HF plus X HFG. This is the equation given. So X value is 70%, 0.7, HFG value we have from the steam tables. We calculate, and this one. So this answer what you have gotten, I have told you. Again, we are getting for how much? 1 kg of steam itself. We need for how much? 3 kg of steam. So for 5 kg of steam. So this is the value we multiply, and the final answer we get is 10,110.7 kilojoules. So these are the things we need to know when we are solving the problems using the steam tables. So once again, I say you students that if you have any doubts for referring the data, or for any of the doubts if you are having for conversions, you can email me so that I can clear your doubts as early as possible. So these are the things we need to understand. Thank you, students.